Hey everyone, so this is going to go over week 7, lesson 1. We're going to continue off of what we've been learning with combining like terms. And last week we did perimeter of different shapes. This week we're going to do area of shapes. All right, so this is the assignment that you are actually going to be working on for lesson 1 this week. If you do notice, you have 2 example problems at the very top here. So those 2, in case you forget. You also have the area formula for a rectangle or square, area formula for a triangle right here. You do have an answer bank to kind of help you out if you do get stuck. So make sure to be paying attention to all those parts. So this lesson does have 6 problems. You have the first 3 problems done on the first slide, and then the second slide has the next 3 problems. Notice on this one, number 6 is a circle. So you need to make sure that you pay attention to that area formula for a circle. Notice it's a full circle, so there won't be any dividing by 2. Again, we're using 3 for pi. And this slide also has an answer bank for you to double check your work. Okay, so now I'm going to actually be going through some example area problems for you guys. I'm going to do 3 examples. I'm going to do the rectangle, the triangle, and a circle example. So please make sure that you're paying attention. Also, I will be going through this using the anchor chart notes example problems, going through these steps. That way you can have an idea of how to tackle these problems step by step. So again, the directions tell me that I need to write an expression to find the area of the figure. And then once I've written that expression, I'm going to simplify it by combining like terms and so forth. So let's start with step 1. So step 1 in our anchor chart notes says that we need to write an expression to find the area using the side lengths. Well, I know this is a rectangle, so my side lengths here are going to be 4x and 8x minus 5. So then notice that my area formula tells me that I'm going to multiply the base, which is this, times the height of the figure. So I'm going to write area equals my base, which is 4x, times the height, which is 8x minus 5. Next, I'm going to, for step 2, use the distributive property to help me to multiply the base and height. Notice that I have these 2 parentheses here. One was my base, one was my height. So I'm going to distribute this out. So I have a 4x times 8x, and then I have another 4x times that negative 5. All right, so I'm multiplying 4x times 8x. Now, as I'm doing the multiplication part, I have to remember about my exponent rules that we did a few weeks back as I'm combining like terms. So I am multiplying 4x times 8x. So of course I'm going to multiply first the 4 times 8. So I have 4 times 8, and that's going to give me my 32. But I also have to remember that I'm multiplying x times x as well. So according to that product rule, I'm going to be multiplying x times x. So then that becomes an x squared because I am adding those 2 exponents together because this has a 1 exponent, this has a 1 exponent. So because I'm multiplying them, I know I'm going to be adding their exponents. So it'll be x squared there. So I've multiplied 4x times 8x. Now I have to multiply that 4x times that negative 5. And that part, I'm going to multiply the number part, of course. So 4 times negative 5 is negative 20. X isn't being multiplied really by anything over here, so we can just bring that x down. And then I'm left with negative 20x. Now I can put everything together for my area is equal to 32x squared, which comes from over here, minus the 20x, which comes from over here. So this ends up being my final answer for the area of the square. So now in this example problem, I'm going to go over how to find the area of a triangle using the combining like terms and simplifying and so forth. So again, our directions: write an expression to find the area of the figure, then simplify the expression by combining like terms. So I'm going to go according to the notes again with our steps. So step 1, we're going to write the expression to find the area using the side lengths. So if you notice, the area formula for a triangle is base times height divided by 2. So we have our base, which is 14x. So area equals 14x. And we're going to multiply it by the height, which is 5x plus 10. So multiply 5x plus 10. And now all of this is going to be divided by 2. We can do that part probably at the end. So now we are at step 2. So we're going to use that distributive property to multiply the base and the height on the top of the fraction. So kind of like the rectangle problem that I did right before this, we have to multiply that 14x times 5x and also by the 10. Okay, so I wrote out the formula showing my distribution part. I've got the 14x times 5x, and then I've got the 14x times that positive 10, all divided by 2. So now I'm going to actually distribute and use what I know about exponent rules to combine like terms once I've done the multiplication part. So let's start first with the 14x times the 5x right here. So again, first multiply the two numbers. 14 times 5 is going to give me 70. And then, of course, I still have to multiply the x times x. And again, according to the product rule, if this has a degree of 1, this has also a degree of 1, I can go ahead and add those two exponents. So that ends up being x to the power of 2. Now I'm going to do the same thing over here with the 14x and the 10. So 14 times 10 gives me 140. This x is kind of a standalone, so I'm just going to bring that down. It was positive, so I'm going to bring that positive down. And then I'm also going to make sure that I put everything divided by 2. So once I've done the multiplication part, I can actually now do the dividing part if I cannot combine anything on the top. So if you notice, this right here has a degree of 2. This one's degree is only 1, so I cannot combine them because they don't have the same exponent. Remember, I can only combine if they have the same exponent. So because I cannot combine anything else, I'm going to go ahead and just start dividing the numbers by 2, or the coefficients, I should say, by 2. So 70 divided by 2 is 35. I'll write that on side. 70 divided by 2 is 35. So this whole part becomes 35x squared. Notice nothing happens to the exponent right here. Then I'm also going to do the same thing on the opposite side. I'm going to take 140 and divide that part by 2. That gives me 70. So again, I'm going to take this whole part right here. It is positive because that positive right there. So positive 70x. Notice again, nothing happens to the exponent. So then I have area equals 35x squared plus 70x. I cannot combine anything together because both of those x's have different exponents. So this would be my final answer for my area. All right, so in this last example problem, I'm going to go over the area of a circle and then also area of a half circle. So the directions are exactly the same as the last two problems. We're still writing the area expression first, and then we're going to simplify it by combining like terms. We may use the distributive property, kind of like how we did before, and so forth, or the exponent rules as well. Okay, so here again is that area formula. area equals pi r squared, or r to the second power. For the pi symbol, we're going to be using the number 3. So make sure to substitute or plug in that 3 for that symbol of pi. So notice that this r is in the formula right here. That r stands for the word radius, if you've forgotten from last year. And radius is half the diameter of a circle. So notice the diameter would have gone all the way through the circle. The radius is only halfway through. So our radius in our circle is only 2x. So we're going to use that for our formula. So our area is going to be, now again, we're going to use the number 3 for pi. So 3 times 2x, and then that radius has to be to the power of 2. So we have our expression written, area equals 3 times 2x to the power of 2. So something that we also have to think back to is PEMDAS. If you remember PEMDAS, it stands for parentheses, exponents, multiplication, division, addition, and subtraction. So the first thing we want to always check as we're simplifying an expression is the parentheses. So I do have these parentheses here. I notice that the 2 and the x cannot be combined together right away. So I'm going to go straight to the exponent part next. So that means as I work through this problem, I'm going to want to tackle this part first. Now I have to remember exponent rules. So this right here is a power rule. So the power rule tells us that we're going to multiply this 2 times the exponents inside of the parentheses. 2 has an exponent of 1, x also has an exponent of 1 because there's only one of each. So really I'm going to multiply this 2 times 1 and then 2 times this 1 again. So if I did that, I would have area equals 3 times 2 to the power of 2 and now x to the power of 2. So then I look at this and I see, oh, well, I actually do know what 2 to the power of 2 is. So 2 to the power of 2 is just 2 times 2, which equals to 4. So then I can simplify that further. Area equals 3 times 4 x to the power of 2. So there we go. Next up, I can go ahead and do either multiplication or division. Since this is a full circle, I don't have any division to do. So I'm going to keep it as is and just do my multiplication, kind of like that distributive property part. So my area is equal to 3 times 4, which is 12. And then x squared I also bring down. So my area is equal to 12x squared. Now I cannot combine 12 and x squared, so this ends up being my final area for that full circle. Now if the circle was actually just a half circle, kind of like this one down here, notice that they have the exact same radius, which is 2x. So I would just end up taking this one step further by saying if the area is 12x squared for a full circle, I would just take that and divide it by 2. So then I would take those two numbers, divide them by 2. So 12 divided by 2 is 6. So then the area of half of the circle is actually just 6x squared. And that would be the area for the half circle. I am very proud of you guys. You guys have been doing very well. If you have any questions, please feel free to leave me a comment on your assignment. I will try to look for some other videos to help guide you. I am trying to post a video for each assignment for this week to help with the example problems and so forth. I hope you guys have a great week. Bye.